Hello everyone. Now we're starting a third device that is called as a Varactor diode. Varactor diode, as name itself indicates, as it is a diode, so it is consists of PN junction. It consists of PN junction. So basically, the Varactor diode is nothing and PN junction diode, which is operated in reverse bias. So we know very well the definition of capacitor. Two conducting plates are separated by dielectric material. Two conducting plates separated by dielectric material. So ultimately, its operation, the operation of the Varactor diode, depends on the variation of depletion layer. Variation of depletion layer. The variation of the depletion layer capacitance, the depletion layer capacitance will called as a transition capacitance. Will known as a transition capacitance, which is depends on the value of reverse bias. So we can say that the operation of the Varactor diode, it depends on the variation of depletion layer capacitance, which is known as a transition capacitance, and that transition capacitance will changes by changing the value of reverse bias. This is the reason, as we changing the reverse bias, the capacitance will be changed. That's why it is called as a voltage cap or voltage variable capacitor. Voltage cap, volt cap, or voltage variable capacitance. This variation, we know very well the variable capacitance are basically or mainly used in the tuning circuits. That's why sometimes the Varactor diode is also named as a tuning diode. It is also known as a tuning diode. The transition capacitance, which is depends on the variation or a width of the depletion layer, that value can be given as epsilon A upon W. Epsilon A upon W, where the CT is nothing in a junction capacitance. Epsilon, that is called as a permittivity of the diode material. The permittivity of diode material, where A, that is called as a cross-sectional area of the junction. A is called as a cross-sectional area of the junction, and where W is called as a width of depletion layer. Width of depletion layer. Therefore, as shown, CT is equal to epsilon A upon W. Thus, we can say that a variation in reverse bias. The variation in the reverse bias will cause the variation in the depletion layer. The variation in the reverse bias will cause the variation in the width of the depletion region. And by changing the width of the depletion region, the capacitance will be changes. And you can determine the capacitance. So this is the Varactor diode principle. Varactor diode principle, which transition capacitance is given by the variation of depletion line. Next is construction of the Varactor diode. Basically, we are preferring two types of doping in the diode. Two types of the doping. One is called as a abrupt junction diode, and one is called as a hyper abrupt junction diode. See, the two graphs are shown over here. Which is showing the doping level, So the abrupt, the left side graph is called as a abrupt junction diode, which has uniform doping, on the either side of the junction, and because of that, as it having a uniform junction, see, it's shown in the graph, its line will suggest that there will be a uniform doping at the junction, and due to this, the reverse bias, this diodes the depletion layer width will be changes such that the value of transition capacitance is ranges from 100 picofarad to 25 picofarad in the abrupt junction diode, and this is the large frequency range. This is a large or sufficient for the tuning large frequency range. Whereas in the right side, the hyper abrupt junction diode has a highest doping level at the junction. See, this is the highest doping level at the junction, and it goes away from the junction, the doping will be decreases, and this reduces the width of the depletion layer. This will reduce the width of the depletion layer because of having a larger doping at the junction. The width of the depletion layer will be decreases, and as the width of the depletion layer will be increases by equation Ct is equal to epsilon A upon W. As the width is decreases, so ultimately capacitance will be decreases. So that the Varactor diode is used for the tuning circuit for its variable capacitance. For its variable capacitance. And next is a working. How it behave? As we know very well, the one PN junction diode will connected in reverse bias. The depletion region, whenever the junction created, the depletion layer will be created, and that depletion region of the PN junction diode not have a free charge carriers, it having immobile charge carriers. The depletion layer is consist of immobile charge carriers, and that behave essentially like an insulator. And the two material p-type and n-type can act as a two layers. So we can say that no free charge carriers layers, that is depletion layer, will behave as a dielectric material, and two layers p-type and n-type will act as a two plates, and thus a PN junction diode can be, or a PN junction can be considered as a capacitor. Since the depletion layer width of the depletion layer will be increases by increase the reverse bias. So we can say is that if reverse bias increases, the width of depletion layer will be increases, resulting in the transition capacitance will be decreases. So that whenever diode is in forward bias, we have diffusion the capacitance. Because at the time the depletion layer will be no depletion layer because of the forward bias. Whenever the forward bias is given, so it diffuse the capacitance or storage capacitance. It should be noted that for the reverse bias, we have a transition capacitance, and for the forward bias, we have a diffusion capacitance. As shown in the circuit diagram, see the p-type material, n-type material, between them the depletion layer which is act as an insulator, and this is positive plate, this is negative plates, so junction can behave as a capacitor. One graph is shown over here, graph between reverse bias and transition capacitance. As shown in the graph, a Varactor diode is changing the corresponding value of the transition capacitance is also changes by changing the reverse bias. But for the variation of CT with respect to the VR, the variation of the CT with respect to the CR is shown in the graph. Where its symbol is shown over here, the diode. This is called as a diode, this is called as a capacitor, and this is called as a variable capacitor. So this is a symbol of the Varactor diode. So this is about the Varactor diode.